Welcome to the Dev Journal. We are witnessing a massive shift as high-fidelity autonomous agent architectures like GLM 5.1 and Gemini take center stage. This technological surge is triggering a historic wave of infrastructure, spending with industry titans, committing hundreds of billions of dollars in capital expenditure to keep pace with the demand. We are tracking how these systems are already changing the world of security and commerce. Later, we examine Claude code, uncovering a 23-year-old Linux security flaw that had been hiding in plain sight for decades. We also evaluate the strategic shifts at Amazon as satellite acquisition talks and price hikes reshape the landscape of the digital economy. These moves suggest a desperate race for dominance in an environment where software builds itself and systems manage their own vulnerabilities. But before we get to the corporate strategy, we need to analyze the raw engineering breakthroughs that are making these agentic workflows possible across the entire global cloud infrastructure and the massive data centers powering them.
The focus on infrastructure that Sloan mentioned is underscored by the 754 billion parameter GLM 5.1 model. It just set a new record for software engineering benchmarks, and it is entirely open weight. I want to dissect how the Gemini application programming interface is now mastering complex tool combinations and context circulation.
The release of GLM 5.1 marks a definitive shift in how we perceive autonomous engineering. By securing a state-of-the-art score of 58.4 on the Software Engineering Bench Pro benchmark, this model has effectively moved past the era of simple human-in-the-loop coding assistance. It is particularly striking how this system outclasses established giants like Claude Opus 4.6 in long horizon tasks. We are no longer looking at agents that just write boilerplate code. We are seeing a sophisticated intelligence capable of managing complex, multi-layered software projects with a level of autonomy that was previously considered purely theoretical. Consider the sheer depth of its performance engineering capabilities, where it achieved a 35.7 times speedup on a CUDA kernel. Through 178 rounds of autonomous iteration, the model demonstrated it can refine and optimize low-level code far beyond the initial 2.6 times gain seen in earlier versions. This shift toward truly independent agents suggests a future where the bottleneck is no longer human typing speed, but our ability to define the desired outcome. If a system can iterate nearly 200 times on a single vector database task to improve performance by 50%, the role of the senior developer changes from builder to architect.
That architect role depends entirely on the stability of the underlying engine, and I am zeroing in on that 754 billion parameter mixture of experts' design. The integration of dynamic sparse attention is the only reason this model can keep its head straight across a massive 200,000 token context window during long tasks. My concern remains with the sheer difficulty of maintaining goal alignment during an 8-hour execution window. When you are asking a model to make thousands of autonomous tool calls, any minor deviation in its reasoning path can compound into a complete failure, requiring incredibly strict hygiene within the mixture of experts routing logic to avoid drift. We also have to look at the practicalities of deployment using tools like K-Transformers or SG-Lang version 0.5.10. Even with these optimizations, the hardware requirements for a model this size are staggering, making me wonder if the marginal gains in engineering benchmarks justify the massive computational tax paid by the developers. The conversation is clearly shifting from how these models think internally to how we actually plug them into our existing stacks. We need to pivot from the model's internal reasoning capabilities to the practical application, programming interface protocols required to connect these agents to real-world tools.
The March 2026 update to the Gemini application programming interface fundamentally changes how we handle real-time business logic. By executing Google Search and Maps grounding simultaneously within a single tool object, developers can build agents that verify inventory lookups against live location data. This turns a simple bot into a context-aware engine, The introduction of the Include Server-Side Tool Invocations flag within the tool configuration is the mandatory trigger that makes this possible. By enabling this, the model manages autonomous context circulation across different services without constant human intervention. It allows live grounding data to directly inform the parameters for your own custom business logic. Even the user interface gets an upgrade through specific widget context, tokens for Google Maps integration within the Gemini 2.5 and 2.0 Flash models. This means a customer can receive a shipping estimate that is grounded in real-time geographical data. It represents a sophisticated bridge between abstract reasoning and the physical world.
While the potential for utility is high, the implementation burden placed on the engineering team is significantly more demanding than the marketing suggests. You cannot just fire and forget these requests because parallel tool execution requires strict management of every function response. Every single return must include a unique identification field that matches the specific call. If you fail to pair these correctly, the system misattributes critical data, which is a total nightmare for workflows involving thousands of stock-keeping units. One mismatched identification, and your inventory lookup is suddenly using the coordinates for a different warehouse. The reliability of these agents hinges entirely on maintaining perfect synchronization across many asynchronous calls. There is also the matter of the thought signature, which must be included in every subsequent call to the application programming interface to preserve the reasoning chain. Without passing that signature back and forth through the multi-turn history, the model loses its internal logic path. It is a massive amount of metadata to manage just to ensure consistency. We are essentially asking developers to act as high-stakes state managers for a black box reasoning engine. While grounding provides impressive real-time data, the overhead of handling server-side tool invocations can become a performance bottleneck. It requires a level of precision in code that many existing enterprise software stacks are simply not ready for. This technical overhead is the price we pay for giving these models the keys to our live systems and legacy databases. As we move from the mechanics of building agents to the actual security consequences of letting them loose on legacy code bases, the risks multiply. We are seeing models uncover vulnerabilities that have existed for decades.
The scale of what Anthropic Claude Code just accomplished changes the way we think about legacy software safety by identifying a 23-year-old heap buffer overflow in the Linux kernel that has been hidden since March 2003. It shows that our most trusted infrastructure is still remarkably fragile under the lens of modern reasoning models. This breakthrough is creating a massive administrative crisis for the people who actually maintain these open-source projects. The Linux Foundation has already established a $12.5 million defensive fund to help manage the overwhelming surge of vulnerability. Reports that human developers can no longer keep up with alone while maintaining their current security posture. Beyond just fixing old code, we are seeing the groundwork for how these agents will actually trade value. The new X402 protocol from Coinbase and Stripe is a major step towards standardizing machine-to-machine payments, providing the necessary financial layer for autonomous agents to operate independently in the global economy. It feels like we are finally moving past the theoretical phase of artificial intelligence and into a period where these tools are actively reshaping both the security and the economics of the internet. Vance, how are you reading the technical implications of a model finding bugs that have survived over 2 decades of human scrutiny?
That specific heap buffer overflow in the version 4.0 replay cache of the network file system is a perfect example of how automated loops find edge cases we miss. By running Claude Opus 4.6 through continuous cycles, researchers validated over 500 high-severity vulnerabilities in just a few weeks. We are also seeing the operating system itself evolve to accommodate this high-performance future. Linux version 7.1 is officially dropping support for the ancient i400 an 86 processor architecture by mandating modern instructions. This move sheds decades of legacy. Wait to optimize for the intensive workloads these new models demand. However, the capability to find these flaws also means the capability to exploit them, as seen with the Avocado model from Meta, which can generate offensive cybersecurity code. This duality is forcing a much more restrictive approach to how these weights are released to the public, as the risk of automated exploitation becomes a very real threat.
The technical achievements of these models are truly breathtaking, but they also highlight a massive shift from the technical achievements of artificial intelligence to the massive financial cost and market volatility associated with building the infrastructure to support them. This leads us directly into the upcoming earnings catalyst for Microsoft and their 21-day outlook.
Looking at the technical indicators for Microsoft, we see a relative strength index sitting at 35.15. This level typically signals that the stock is deep in oversold territory. Despite the broader market jitters, the current price of $374.33 appears to be reaching a bottom. The market seems to be punishing the company for its massive commitment to spend between $100 billion and $120 billion on infrastructure in 2026, while the stock has suffered a 25.8% decline so far this year. This heavy capital expenditure is building the backbone for future computing. We cannot ignore the core operational health here, as the company maintains a net margin of 36.15%. With $71.61 billion in trailing 12-month free cash flow, they have the liquid resources to fund these aggressive investments without compromising their balance sheet for the long term. As we approach the earnings catalyst on April 29th, analysts are holding firm on a price target of $587.31. This suggests a massive upside that traders might be overlooking. Sloan, how do you see the human side of this equation when the numbers are so aggressive?
The sheer scale of spending between $100 billion and $120 billion is difficult to comprehend when you see Azure cloud revenue growth slowing to 28%. Investors are clearly questioning if the immediate return on investment for artificial intelligence infrastructure justifies the staggering price tag that management has committed to for the upcoming fiscal year. A 25.8% year-to-date decline in stock value suggests a significant crisis of confidence. While a 36% net margin is impressive, it does little to soothe the anxiety of shareholders who see massive capital disappearing into data centers while the primary growth engine for the cloud begins to decelerate. If Azure growth drops even slightly below that 28% mark, the bear case scenario could push the stock price below $353.10. We are witnessing a high-stakes gamble, where the company depends on artificial intelligence delivering tangible profits faster than the massive infrastructure costs accumulate. This struggle to balance astronomical infrastructure projects with the need for steady free cash flow is not unique to Redmond. We are seeing a very similar tension play out with Amazon as they attempt to reconcile their own massive cloud spending with new revenue streams like the Prime Video price hike.
Those price hikes provide some relief, but the potential $9 billion acquisition of Globalstar represents a much larger strategic pivot to bolster the Project Kuiper satellite network. This move confirms that leadership is willing to sacrifice immediate liquidity to ensure they can compete directly with SpaceX for cloud customers. This massive infrastructure expansion comes at a steep price for shareholders. With capital expenditures reaching $131.82 billion, the free cash flow has been squeezed down to only $7.7 billion, leaving very little margin for error if technical snags occur. Market participants are seeing the consequences reflected in the charts already. The stock recently triggered a technical death cross and continues to trade below its 100-day simple moving average, suggesting that technical traders are not yet convinced that the long-term satellite play justifies the current burn rate. Everything now hinges on the upcoming April 30th earnings report to prove these investments are generating real returns. Sloan, do you think the average consumer will feel the weight of this massive infrastructure bill when they check their monthly subscription statements? Or will they just see it as the price of convenience?
Consumers will certainly feel the impact starting April 10th, when the price for the Prime Video Ultra tier climbs from $2.99 to $4.99 per month. This is a low-friction way for the company to capture more value from its base. Bank of America estimates this price adjustment will generate $780 million in incremental annual revenue. While it seems small compared to their total budget, it provides a crucial buffer to help offset the astronomical costs associated with expanding the Amazon Web Services footprint globally. Beyond the immediate revenue, this satellite push is really about bringing cloud power to the most remote corners of the planet. By integrating Globalstar assets, they can provide a unique edge computing solution that makes their logistics network more resilient than any of their traditional cloud competitors. Maintaining that 10.83% net margin remains the difficult priority despite these massive outlays for technical expansion. It is time to move from these diversified giants to Tesla, which is facing margin contraction without the same cloud revenue safety net to catch them if things go south. Tesla is hitting a significant wall as we look at the first quarter delivery numbers. Reporting only 358,023 vehicles is a tough pill to swallow when Wall Street was banking on 365,645. This represents a 14% sequential decline, suggesting the core engine is cooling. We are seeing a 10% drop in automotive revenue specifically, which puts immense pressure on their broader ambitions. When your primary source of capital starts to dry up, it becomes much harder to justify the massive research and development spending required for their next-generation artificial intelligence and robotics initiatives that investors crave. There is one bright spot in the portfolio that managed to defy the downward trend this quarter. The energy storage business grew by 49% year-over-year, providing the only real momentum in the report. This segment is essentially the only thing preventing the fundamental sentiment from shifting into a completely bearish outlook for the year. While the energy growth is impressive, the 46.79% year-over-year drop in earnings growth indicates deep structural challenges. Investors are watching closely to see if the company can maintain its lead in the electric vehicle market, while simultaneously pivoting toward a future dominated by autonomous software and high-density power solutions.
Considering that energy storage surge you highlighted, I must point out the brutal reality of the underlying margins. The gap between the 18.03% gross margin and the 4.00% net margin is alarming. For a stock with a high beta of 1.92, that compression leaves zero room for error. It is very difficult to reconcile a price-to-earnings ratio of 320.79 with these cooling fundamentals. The market is still pricing this as an aggressive artificial intelligence company, yet the drop in automotive revenue reveals an entirely different set of challenges. This valuation makes every minor production miss extremely volatile. Looking at the charts, the 14-day relative strength index has dipped to 31.99, which technically puts the stock in oversold territory. Despite the bearish sentiment, there is a significant delta between the current price and the average analyst target of $416.15 as we approach the next reporting date. Everything now hinges on the April 22nd earnings report to see if internal efficiencies can match the bold technological promises. This high-stakes moment perfectly illustrates how the technical prowess of new models must eventually translate into sustainable financial performance during this critical and volatile earnings season for the entire tech sector. The leap to 754 billion parameters in GLM 5.1 proves that agentic models are a structural evolution in software engineering. When you combine that scale with the sophisticated tool circulation in the Gemini application programming interface, the technical bar for autonomous systems has fundamentally shifted.
Vance, those engineering leaps explain why we are seeing such a massive capital expenditure cycle from the hyperscalers. Microsoft and Amazon are betting hundreds of billions of dollars on the belief that these autonomous workflows will redefine productivity, turning technical risks into the essential foundations of the next global digital economy. As these agentic architectures transition from the laboratory to the enterprise, the question shifts from whether the technology works to how quickly we can build the physical world to support it. We appreciate you joining us for this technical journey. Stay curious, stay analytical, and we will see you back here next time.